To finish things off here with section 8.3, we're going to take a look at some integrals that involve some sine and cosine products with different angles. And what will happen is that you won't see exponents attached to the sine or cosine anymore. You'll just see sort of what we call different arguments after the trig function itself. Like in example 8, we see sine of 5x times the cosine of 4x. And evaluating these integrals is sort of a catch-22 proposition. There's good news, there's bad news. The good news is they only take a couple of steps to evaluate. So really in that regard they're quite simple. They don't have the rigorous algebraic steps and things of that nature. The bad news is that they're heavily reliant upon a trio of formulas that you can see here in the box that is just yet another thing sort of to add to the old memory banks when it comes time to prepare for the different assessments and ultimately the AP exam. And probably the best way for a student to get around memorizing these effectively is to realize that in each case you have a 1/2 coefficient out at the very beginning. Notice that when your two trigonometric pieces or words are the same, like if we're both sine or if they're both cosine, we're dealing with cosines in the formula. It's only when you have one of each, a sine and a cosine, as we will here with example 8, that you have sines is your result. Now outside of that, several things seem to be consistent in that your first component, your first term, is always going to consist of an m minus n form. So you'll subtract the first angle minus the second angle that you see. And then in the second term, you'll add those two coefficients of your angles. Now the other thing that's a little bit of a nuisance and that you're going to have to very much stay on top of is the fact that in the sine times sine formula, that's the first one, you would subtract those two results. Whereas in the other two cases, you'd be adding. So if you look at our example 8, it becomes pretty obvious that that's going to mimic the middle of these three rules, in that our m value would be 5 and our n value would be 4. I can go ahead and write those here. It's not like you would have to write those out. I think you can carefully keep track of those in your head. So before we do any integration or anything like that, we're just going to use a little bit of a trigonometric identity here, a very little used one I think that you were faced with in your trigonometry class. But the sine of 5x times the cosine of 4x is indeed equal to 1/2 times the quantity sine of the subtraction of the two angles, 5x, or the coefficients, let's say 5 minus 4, which is 1, and then you've got your x, plus, your middle sign is plus in the case of sine times cosine, the sine times the sum of those two values, m and n, which is 9 times your x. And that's really all there is to it. Nothing really else needs to be done to this in terms of integrating it. It's all set to go. The integration of sine would be negative cosine. Let's go ahead and put this 1/2 out in front of it all. And we'd have negative cosine. That should be a minus sign there. Now when we integrate sine of 9x, you've got a little bit of a u substitution here where u is 9x. The derivative, of course, is going to be 9, so we're going to have to offset with a 1/9. But we're going to have a minus also generated as part of our result because the integration of sine is going to be negative cosine. In this case, it would be negative 1/9 cosine of 9x plus c. And again, that answer seems fine with me. It doesn't have any issues that I can see. Of course, you could pull out a negative sign. You could multiply through by the 1/2. In any case, you're looking at a correct result.